Hi, my name is Dean Zodi. I'm founder and CEO of Ghostwave, and we are a radar company based here in Ohio. After our lovely 7 minutes here, hopefully you will understand on what do drones and honeybees have in common, and that's besides the fact that they both can fly. Ghostwave has 4 patents exclusively licensed to us from Ohio State University, and these are radar patents. The Army went to Ohio State and said, I want something that's going to detect if somebody's shooting at my Black Hawk helicopters. However, this sensor has to be stealthy so that a threat on the ground cannot lock into the signal and then shoot a rocket launcher and blow up the helicopter. So Ohio State came up with RF noise radars. Currently, there's a problem with radars, and they're growing with the proliferation of adaptive cruise control, blind spot detection, lane change assist. Those are radars on your car. And there's a finite number of signals that these current technology is using. With this technology, there's increased opportunities for hacking. There can be intentional or unintentional jamming, and there can be mutual interference where the signals start talking to each other. Ghostwave's technology solution to this problem with radars is we have millions of unique signals that we're transmitting out. That makes us immune from the jamming and interference, and from the Army's point of view, it also made them very stealthy. The solution that we're doing is we use a pseudo-random noise generator. So we're generating millions of random signals, we're transmitting that out while sticking it in a memory, and it's going really fast. But we're also at specific range gates pulling the information out of the memory and comparing it to what's being received by the radar. With that, we have a stealthy radar, but we're getting the same performance as direction, distance, angle of arrival, speed, things that you get with everyday radars. Another way to look at it is, if you remember old televisions with knobs, if there was not a station on that channel, you had all this snow on the TV. Or if you think of AM radio and the static, both those are examples of RF noise. And with the RF noise, Ghostwave is sending that signal in there. It's getting lost with all the RF noise, but we know it's there and we're looking for it to come back to us. Now, how do we compare with the competitors? Right now, we're going to use the chip manufacturers that the Bosches and the Delphis use to make their radars. And as you see here, they use a unique number of chirps, and that gives them the chance to talk to each other or be intentionally jammed by a threat. The benefits of the Ghostwave radar is the immune from jamming, the immune from interference, and the millions of random signals that we're generating allows us to work and play well with the other radars around us. Unique uses of Ghostwave radars include detect and avoid systems for unmanned aerial vehicles or drones. Or with the detect and avoid system, just think of that as if your Domino's pizza delivery drone's coming at your house, you don't want it to run into the house. So it's going to detect it and say, I got to get out of the way and make evasive maneuvers. So right now, detect and avoid, and they will be, detect and avoid systems are critical for UAVs or drones. And right now, currently the FAA says you cannot fly your drone beyond visible line of sight. However, in the near future, it's expected that the FAA will allow that. But to allow that, you're going to have a closed loop system for detect and avoid. In other words, you're not going to rely on somebody on the ground. It's going to be all internal. If there's a problem, it gets out of the way on its own. Well, there's detect and avoid problems. And it's such a big problem that the federal government, FAA, is working on solutions, and the state is working on solutions. And actually, they're funding us for a solution. Ghostwave is capitalizing on this detect and avoid solution by a collaboration with Lockheed Martin. We have a $2.5 million contract with Ohio Federal Research Network, and that was awarded last year. And what we did was we said, okay, most drones out there come with a camera. That's part of the drone, but cameras don't work well when it's smoky, cloudy, or rainy as far as that goes. And we're going to combine the camera now with a radar, but as we mentioned earlier, radars are prone to jamming and interference, so we use a Ghostwave radar. With that, we do a sensor fusion of the camera, the Ghostwave radar, and we feed that output into avoidance algorithms, and the avoidance algorithms now are feeding the autopilot on the drone. So now you have a closed loop detect and avoid system on your drone. When you look at the available sensors that from a weight and power requirements for your drone, the Ghostwave radar and the onboard camera are the best solution for detect and avoid solutions. Here, this is obviously not on the ground, in the air. This is the Ghostwave radio tracking velocity, direction of travel, and we can track multiple targets at the same time. As it's coming up here, you got two cars going opposite directions. Now, another unique application for Ghostwave radars includes honeybees. Last year in Ohio, over 59% of the hives disappeared through colony collapse, pesticides, infestations, gone. We went to the Department of Agriculture and said, honeybees flap their wings at 210 flaps per second. And actually that was from previous research, not us. However, Ghostwave radars verify it's 210 flaps per second. We also put in the proposal that we've noticed that if there's a change in wing speed, it can be an indicator of a change in hive health. So, Ghostwave can provide early warning before a hive is decimated. Why is this important? Well, 100% of your almonds are pollinated by honeybees. 90% of cherries and blueberries pollinated by honeybees. It's an important part of our whole food chain. The market opportunities, besides just having food, looking at the drones, detect and avoid is $3.6 billion market. That's ground-based, in the air. We expect what Ghostwave can address is a $900 million market by 2022 for detect and avoid systems. Right now, there are 2.7 million hives in the United States. In 2018, 1.6 million of those hives disappeared. Again, colony collapse. It's a big opportunity to get early warning and prevent what's going on. Myself, I have an engineering degree in MBA. Dr. Walton is listed as the inventor and on the patents that are exclusively licensed to Ghostwave. Dr. Villarol has spent 17 years in the auto industry focusing on antennas, and a lot of the great people on the board and on the team helping out Ghostwave. Ghostwave business approach is a little bit different than a lot here. We have a lot of SBIRs, or Small Business Innovation Research grants. And what this is doing is, first of all, we're working on projects that the Department of Agriculture, Department of Defense say these are big things that need to be addressed. So the market is validated because they're funding this project. Secondly, this has given us non-dilutive funding to work on these projects. And because we're early in on the solution, Ghostwave's helped writing the solutions for the marketplace down the road when this becomes commercial products. Our ask right now, there's been $350 million invested in the drone industry in the first half of this year. When our OFRN contract ends in April of next year, we're going to take steps towards having a commercialized product. That time, we're going to start beginning a large fundraising raise. So, at this point, if you know anybody who's interested in investors, we'd like to talk to them now, get them all lined up. So in second, third quarter next year, we're ready to go. And the interns rock.